So I want to talk a little bit today about the lighting aspect of television studios, as well as what you might encounter when you're out in the field. And by lighting, if you look above my head, I'm talking about all these different little instruments that are designed to provide light for a studio. So that's what we're going to talk a little bit about today, is the properties of light for television purposes, whether it's in a studio or if it's going to be out in the world of ENG. So when we're dealing with light, we're also dealing with colors and images and everything that you can see with the eye. And light works in a different color spectrum than colors like paint and things that you have physical. So when we're dealing with paint, we're dealing with colors like red, green, and blue. Or when we're dealing with light, we're dealing with red, green, and blue, as opposed to like when we're mixing colors of paint, we've got like red, yellow, and blue, because light and pigmentation works a little bit different. But in the end, it's all about what we're able to see, what colors, what images, and how we capture that. So basically, whenever you look at something, you notice that it has colors. And the way this works is, in an entire spectrum of light, you've got an entire rainbow of colors: red, yellows, greens, blues, violets. And when they bounce off a surface like a white surface, you get all of those colors coming back at you, and this comes at you as a white color when we're combining all these. If we're dealing with a black surface or a dark surface, this is actually absorbing the light as opposed to bouncing it back towards your eye. So this is one of the reasons why dark surfaces, you don't see as much light around them, is because they're absorbing all the lights and all the colors in the spectrum. Now, when the surface has a particular color, what it's now doing is it's absorbing every color in the spectrum except for what's being reflected. So in the case of this apple, the red of the apple skin is absorbing the greens and the blues, and it's bouncing or reflecting that red light off of the skin towards your eye. And this winds up, this is how you see an apple. Likewise, with this green leaf is absorbing the blue and the red, and it's reflecting the green light into your eye. And so when this light hits your eye, it goes through the lens and the pupil, and it focuses it on the back of your eyeball. And in the back, there are these sensors known as rods and cones that can detect light and dark and color in images. And so there's cones for red and green and blue, and they're able to understand those different values. So likewise, if you're looking at a banana, and with a banana, it starts off as a green color, so it's absorbing every light but green. But then as the skin changes through different aspects of banana's life, it'll go from a green to a yellow, and thus the yellow spectrum is what's reflected into your eye. And then it may go on into black, where it's absorbing those colors, and you're now seeing kind of that absence of light as a color. And so for a camera, it works pretty much the same way. Now, we can't see without light, and neither can a camera. With our eye, with a human, we have an eye that accepts the light and stores it into the back, or focuses it into the back. For a camera, they have something similar. They have what's called a charge couple device, which is a chip that has multiple sensors. So it has a sensor for blue and green and red, and this CCD, this chip, is able to capture that image and save it as a data file, or transfer it over to media such as a SSD card or other types of things, so it can be played back, and those three channels can be reassembled. Now, one of the things that's going to come into play with the camera and with our eye is what's known as a contrast ratio. And this is a ratio between the light and the dark of an image. So the human eye actually has two contrast ratios that it's dealing with at the same time. The first one is known as a static ratio, and this has a very narrow field of about 100:1 between light and dark. And so what you're doing is, when you look at something, your eye is looking at a specific pinpoint, and then your eye moves a little bit, and then it moves a little bit, and it's picking up all these different pinpoints to build an image. So all this is kind of processing simultaneously at the same time. Now, once you take all these little pin pieces and you're putting them together, you're able to build what's known as the dynamic ratio. And this is going to include things that are in your peripheral vision that your main focus is not looking at. So in this case, I'm looking straight at a camera, but I can see out of my peripheral vision a lot more. I can see things that are going on around me, behind me, off to the side. And so this peripheral vision and this this peripheral view is known as a dynamic ratio. And this has a much bigger ratio of about 1,000,000 to 1. So this allows me to see a lot of variations between light and dark. This also gives me the ability to be inside and to look out a window to see what's happening outside. So with the window next to me, I can see that inside my office it's relatively dark, but on the outside of the window it's very bright. And that dynamic ratio is allowing me to adjust my focus for both indoors and outdoors so I can see it at the same time. Now, cameras, they're not as good as the human eye, so they have a much more limited contrast ratio. So instead of 1,000,000 to 1, they're probably at like 1,000 or 2,500 to 1. So they're not able to focus on light and dark as well as the human eye. And so because of this, they can't really handle shooting both indoors and outdoors simultaneously. So with the human eye, I can use the dynamic ratio to see both inside my office. I can see the computer, the laptop, I can see the books and the flower, and then I can look beyond into the glass outside, and I can see that much brighter video. With a camera or a static ratio, you're either going to have one or the other. You can't have both. So in the middle picture, I'm able to see, again, the laptop and everything on the desk, but I can't see anything outside because it is too bright for the camera to comprehend, and it's beyond their scope of that static ratio. So if I take the iris and I shrink it down so that I can now let less light into the camera, and I can see the outside of the window where now I can see the trees. But the problem is I've now made everything inside extremely dark. So you're either going to wind up being able to shoot outside or inside, but not both, because your camera is going to have a major issue trying to adjust for either one or the other. So it's either going to give you a very dark inside or it's going to give you a very bright outside. So let's take a look at a video, and this is going to be a story that was shot inside a no, I'm gonna pause. I gotta stop. Time it.